Hello, today we are going to do the experiment, that is to determine angle of minimum deviation for a glass prism by plotting a graph between angle of incidence and angle of deviation. For this purpose, what should I require? The things which required in this experiment are white sheet, glass prism, pencil, protractor, eraser, pins, board pins and meter scale. Okay, so let's start the content, what we have to write in the file also. In file we will write down the aim, the material required, theory. In theory we will explain the entire phenomena of refraction of a glass prism through diffraction through a glass prism. Okay, we will just explain all the entire phenomena here in the theory portion. So here we will also write down the prism formula, and here we know that prism formula is basically the formula to find out the refractive index of the glass prism, and that is here n is equal to sine a plus delta m by 2 upon sine a by 2, where this a is the angle of prism, that is 60 degree here, and delta m is angle of minimum deviation, this m for minimum. Okay, and delta means deviation, so delta m refers to the angle of minimum deviation, and this n is the refractive index of the glass prism. So let's begin the experiment now. In the beginning I have just drawn this line, I have just drawn this line using the meter scale, and then put prism over here. Draw the figure of the prism, okay, by drawing the lines like this, and in this side also. Then from this midpoint I have just drawn a normal 90 degree. Okay, this is the 90 degree here. Okay, normal on this face of the glass prism. Let it be A, B and C. Okay, this is the normal at the midpoint of this line AC, and then I have just make an angle. Here this angle is 45 degree. We have to perform the experiment for angle of incidence 30 degree, 35 degree, 40 degree, 45, 50 and 55 degree. Okay, we will perform the experiment for 6 readings. So I have just make an angle of incidence 45 degree. This is my incident ray. Okay, and then after that I will just place two all pins here. Okay, and then after that I will just put the glass prism over here, and then through this phase I will just place the third pin, where these two pins, they are at this side. These two pins will just hide one another. Okay, the third pin. Now just look at this. If you can see, these two pins, through this phase, these two pins, you can see here the two pins which I placed over this side. Okay, now they appear to be single. Okay, that means the first pin is hiding by the second one. Okay, so here these two pins hide and these two pins behave like a single pin. Now what will I do? I will just place a third pin over this side. Okay, over this side I will place a third pin, and that will basically, what will it do? It will just hide the entire two pins. And while doing this experiment we will make sure that the feet get disappear. Now we will not focus on the top of this pin, we will just focus on the feet of the pin. So here I am going to place the third pin over here. Now the third pin, I have placed the third pin, and the two pins on that side, they become invisible. Just look at the, okay, all the, here I am having this pin here. Okay, so it is here. Okay, and other two pins, they are just hiding behind it. Again I will place one more pin. Okay, one more pin in front of the third one, so that now all the four pins becomes in a same line. Now or the 4 pins are in a single straight line. Okay, so from top view we can see that we are having 2 pins this side on incident ray, and here 2 pins this side on emergent side. Okay, so I will just remove these pins, and join the line to this face AC. Okay, after removing the pins and the prism, I will get these 2 points. I will just join them, and the line here, the line which meet AC at this point, I will just draw a normal at this point. Okay, so here I have just drawn a normal on this face AC, on this side AC, this face of the prism, and the angle between this emergent ray, and the normal is angle of emergence. When I extrapolate it in this direction and again extrapolate the incident ray also, then I will get this angle of deviation. This is my angle of deviation. Okay, angle between the incident ray and the emergent ray. This is the angle of emergence. So what will I do? If my practical is correct, that simply means that I plus E should be equal to A plus delta. Okay, I here is angle of incidence, E is angle of emergence, A is angle of prism, and delta is angle of deviation. Okay, I have performed the same process for angle of incidence 40 degree here, and I have just gone through the same process, placed 2 pins over here, and then through refraction through glass prism I place these 2 pins here, remove the pins and join these points, make the emergent ray, extrapolate it, incident ray and emergent ray, the angle, this angle is angle of deviation, that is 36 degree here. 56 degree is basically the angle of emergence when I place normal over this AC, and I plus E is equal to, I here is 40 degree, E is 56 degree, that is sum is 96 degree. In the similar manner, A plus delta is equal to 96 degree. So here I plus E is equal to A plus delta. Okay, so for angle of incidence 40 degree, angle of deviation is 36 degree. Okay, thus you can see it here, angle of incidence 40 degree, angle of deviation is 36 degree. So here for angle of incidence 40 degree I am having delta 36 degree, and for 45 degree I am having delta 40 degree. So initially when I plot the graph between I versus delta, I will get that initially the angle of for angle of incidence the deviation will decreases, which is a minimum value, and then it again increases. Okay.